in welcoming Professor Wu.
So thank you, everyone, and thank you, Professor Chen. So this is a brief introduction of myself. So I graduated from Imperial. I did my PhD at Imperial, and I'm currently an associate professor at Northwestern Polytechnical University in China. My research interests are mainly travel behavior, demand analysis, and its application in emerging mobility services such as urban air mobility and multimodal transport. So this is the title of my presentation today. If you look at the title, you'll find that most of the words are very simple. However, there are two words I marked in red because maybe, so for example, some of you, I think maybe many of you know what mobility as a service is, but some of you may not know. And also occasional activity, that is also a key word of this research. Although you may know, you may understand the meaning of occasional activity on the surface, it might not be the same as what we defined in our study. So the presentation today is a summation of 3 papers we published in recent years with Dr. Liu and Professor Jian from Hong Kong University of Science and Technology. So in case you have not heard about mobility as a service, here's a brief introduction. It is a digital platform-based service that users can seamlessly plan, book, and pay for multiple mobility services. And you can see from the figure that the current situation is if you need to use different modes of transport in a single journey, you need to pay them separately. However, if you have MaaS, you can pay multiple. Okay. However, if you have MaaS, you can pay. So you can pay multimodal trips by one click. That is one major feature of. That is one main feature of MaaS. Another feature is so MaaS can do mobility bundling. That means it can provide services like your current mobile phone plans. Here are some mobility bundles. Example mobility bundles I sourced from Hensher, etc. 2021, and you can see that the horizontal landscape circle are the names of the mobility bundles, and the one on the left are the different mobility services. So you can see that once you pay the subscription fee, you can use the mobility service at a discount price. And usually, the higher the prices, the more discount you can get. So that is a basic idea of mobility as a service. So I don't know how you feel about mobility as a service, but when I first look at that, it makes me think of investment portfolio. Why? Because when we do investment, we need to consider our budget and our risk-taking behavior. And then we need to consider how much money you want to put on each type of investments. For example, how much money I want to put on bonds and how much I want to put in the stock market. So when we subscribe to MaaS, it is very similar because at the time you purchase a MaaS bundle, you need to estimate your future travel plans, your future travel needs, and then choose one that is closer to your future travel demand. However, making this estimation is not always simple because in many cases, well, because of occasional activities, basically, because at the time you purchase MaaS bundles, there will be some activities that is unforeseen. So, for example, in most of your work days, you go from your home to your workplace and then come back. However, sometimes, because your partner is very busy, he or she cannot send the kids to school, so you need to take your kids to school. Therefore, you need to detour in your commute trips. So these unforeseen activities are what we meant occasional activities. And because of these activities, it is difficult for you to estimate your demand at the time of purchasing. Because if this happens, your actual travel demand can be divided from your estimated travel demand. Additionally, purchasing MaaS may influence your travel behavior. And here's another example. So, for example, this lady, she usually drives to work and come back. However, if she purchases such a MaaS bundle, and she may think, okay, there's a 30 hours free car sharing. Why not I use that? So if that is true, actually we can use the design of MaaS bundle to promote users' green travel, right? So therefore, these two are our objectives. So our first objective is to understand travelers' preference for MaaS bundles compared to the current status, which is pay-as-you-go, under uncertainties. And then we want to understand the impact of MaaS and uncertainties on mode choice behavior. So since MaaS has very rare real-world applications, even nowadays, we use data preference survey to collect users' preference data. The survey was generated by the efficient approach, and we generated 24 scenarios. However, to prevent the respondents from fatigue, each respondent is only presented with 6 scenarios. In the 6 scenarios, 2 had no occasional activities. 2 had 50% probability of occasional activities, and 2 had perceived probabilities. So what is perceived probability? It means that we let the occurrence of occasional activities equal to the reported occasional activities by the respondents. So for example, if you tell me that in 10% of your commute trips, there are occasional activities, the perceived probability equals to 10%. So on average, the perceived probability is 23rd, so in our respondents. So you can say that it's kind of in the middle between 0% and 50%. To make the choice scenarios closer to respondents' real experience, we block the respondents into three groups based on their commute travel distance, so short, medium, and long. The survey is in general composed of 3 parts. The first part is their basic socio-economic information. The second is their current travel patterns, and the third, which is a main component of our survey, it is the stated choice scenario. So this is an example interface of our stated choice experiment. The font might be small, but I will introduce each part one by one. So, the first line introduces the probability of occasional activities. So in this case, it's 50%. This part tells you, based on your current travel pattern, what is your weekly travel time and travel cost. Since there are occasional activities, the weekly travel time and travel cost and travel time are uncertain, and they follow a triangular distribution with lower bound, upper bound, and the most likely value. This part, so this table is a MaaS bundle. So we show the respondents the subscription fee of this bundle, as well as the discounts they can get if they purchase this bundle. The respondents can drag the bar here to adjust the use of different travel modes. And in this study, we assume that each respondent commutes 10 times each week. When they drag the bar, this part updates in real time to show, after they adjust their travel behavior, their use of travel modes, what their current weekly travel time and travel cost would be. And once they make a decision, they can click here whether to subscribe to this MaaS bundle or not. So this SP is relatively a complex SP. The survey was implemented in Qualtrics, and we collected data in Hong Kong in July 2021. We collected 1,007 respondents, and the valid sample size is 997. We compared our sample with the Hong Kong population, and we can see that except for the variables in the in the red part, the rest, for example, the gender, the age, and the household size matches the Hong Kong population very well. Since our target are the commuters in Hong Kong, the higher driving license ownership and higher education level also makes sense. So next part are how we model their behavior. So in this study, we use both expected utility theory and non-expected utility theory. So let me first introduce expected utility theory. It means that when encounter choices with uncertain outcomes, the respondents measure the expected utility they can get and then choose the one with the highest expected utility. So here is a function. It looks very complex, but in reality, it is not. So you can ignore this part and let's only focus on the red part. So you can see that I did do weighted average on, what happened? Oh, here. I did do weighted average on the travel time and travel cost. So T is travel time and C is travel cost, and the theta are the probabilities of occasional activities. So this is a linear expected utility theory, and this is our baseline model. Next, let's do something more complex. This model is still expected. It's still EUT, but it is EUT Cairo model, which means, well, this is the original linear utility model you have seen, and we do something like this. So we do some nonlinear transformation on the uncertain travel time and also uncertain travel cost. Why do I do this nonlinear transformation? Because I want to test people's risk attitude. In case you have no idea about what risk attitude means, here is a simple and interesting example. So now I have two options for you. So if you choose A, you can get 5,001 for sure. And if you choose B, you can get 10,001 with 50% chance. Which one would you choose? B, okay. And how many of you would choose A? Only one? I think 90% would choose A. And B? And who are indifferent of the two? You think either A or B are fine? Okay, so this case is on Europe because in most of my presentations, most people would choose A. Okay, so although this case is very simple, I think it clearly shows what risk attitude is. You may notice that either A or B, the expected gain you will get is the same, right? Both 5,001. However, if you still have preferences, that means you have risk attitude. If you choose A, that means you want the certain outcome. You want to avoid risk. So therefore, we call you risk averse. If you choose B, basically you want to bet for the possibility that gain more. That's why you are risk-seeking, because you want to take the risk of getting nothing. And if you are fine with both, you are risk-neutral. Okay, so this is risk attitude. And do you remember that in the EUT carrier model, I did some nonlinear transformations on the utility function? Why? Because the shape of utility functions associate with users' risk attitude. So here are 3 curves. You can see there's a red one, a green one, and a blue one. How they are related? Okay, so I have put line at 5,000. And let's look at, oh, sorry, I made a mistake. Let's look at the red one. Sorry, the line does not show correctly. So the red one, can you see that the utility of 5,000 is less than utility of the average utility of 0 and 10,000? Don't look at this. Look at this. Right? The average of 0 and 10 is at here. But for the red curve, the 5,000 is at here. So that means you are risk-seeking because you prefer the option that's 50% chance you get 10,000 won. And for the blue curve, you will find that it is different from the red one. The utility of 5,000 is greater than the average of utility at 0 and utility at 10,000. So that's the option A. So if the utility of a person is like this, is convex, this person is risk-averse. And if the utility function is linear, the person is risk-neutral. So that's why I want to do this nonlinear transformation, because if I use the linear utility function, I basically force everyone to be risk neutral. However, it is not that case. Okay, let's go back to this slide. So by doing this nonlinear transformation, the parameter R reflects people's risk preference. If the R is greater than 0, this suggests that this person is risk averse to this parameter. So for example, if the RT is greater than 0, it means the person is risk averse to the uncertain uncertain time. But if their R is less than 0 for travel time, that means they are risk seeking to travel time. Okay. So this is our second model, which is a little bit more complex than the first linear model. And let's look at a more complex one. It is a prospect theory-based model, and I will introduce prospect theory very shortly. Let's first look at this model. It looks horrible, but in reality, it's not that horrible. Again, we only look at the first 2 components. And we can say that it is still something about travel time and travel cost. However, I have gains and losses for travel time and travel cost. Why I have gain and losses? Because that is the basic structure of prospect theory. In case you don't know prospect theory, here is a brief introduction. The author of this paper, they won Nobel Prize in, I can't remember which year, but they won Nobel Prize. So this theory describes how individuals examine their losses and gains in a symmetric manner. So this curve is very classic. So next time you see this figure, it suggests that they use the prospect theory. Look at this curve. You can see that so the y-axis is the utility, and the x-axis are the money, and the right part, so this part, are gains, which means you win money, and the left part are losses, which means you lose money. And can you see that the convexity of the curves are different at the gain part and the lose part. So in the gain part, it is concave, which means that when they win money, people tend to be risk averse. However, if they will going to lose money, people tend to more risk seeking. Why is that case? So we have learned. So we have seen an example of gaining money, and let's make it slightly differently. So in the example, we told you that if you choose A, you win 5,000. And let's change it to, if you choose A, you lose 5,000. And if you choose B, you lose 10,000 for 50% chance. So is that clear for you now that why most people would choose B in this case? Because most people want to bet for the probability of choosing B, because if you choose B, there's 50 chance probability of you losing nothing. So this is one. This is one point of prospect theory. Another thing you may notice that the value function is steeper for losses than gains. Okay, so if you look at here and here, you'll find the lose value function is steeper. So this is called loss aversion, which indicates that people in general are more sensitive to losses than gains. Okay, so this is prospect theory, and let's come back. And that's why in this function we have gains and losses, and we have we have some parameters. We have some parameters at here to show the steepness of the value functions. So these are utility functions to describe people's behavior under uncertainty. And for the discrete choice models we used first MNL to assess respondents' overall attitude towards MaaS. And then we used two models called mixed logic and latent class to test people's heterogeneity towards the heterogeneity within their tastes. Since we analyzed the two types of behavior under risks, we propose a way to jointly analyze them. This is very simple, actually. It is so. If you look at this equation carefully, it basically says the conditional probability of people being loss aversion or loss tolerance under when we know that this person is risk-seeking or risk-averse. So this test, so for example, if we know that this person is risk-averse, what their loss aversion level compared to the general compared to the general population. Okay, so these are all these part are our models. And for the main findings, the first one, for MaaS, for MaaS subscription, in both cases with and without occasional activities. First, we find that the coefficient for bundle price is negative. Second, the coefficients for cost and time savings are positive. So this is very intuitive. It shows that if the bundle is cheaper and if the bundle can provide the travelers with more cost and time savings, people will more likely to choose that. The next one is more interesting. We find that car ownership and education level is positively associated. However, high income is negatively associated with MaaS subscription. So this suggests that MaaS, although it is convenient because it integrates multiple travel modes, it cannot replace private car because car ownership positively related to the possibility of choosing MaaS. And second, high income is negatively associated with MaaS subscription. Together with this finding, the coefficient for weekly costs and time saving are positive, it suggests that the primary reason for our respondents selecting MaaS is to save money. The fourth one, if we look at the ASCs of MaaS and pay-as-you-go, we find that when all parameters are controlled, people do not have inherent preference for MaaS. If we look at the ASCs for travel modes, we'll find that the ASA for car use decreased after subscribing to MaaS. However, ASA for taxi become more positive. So to verify the last finding, we examine the our discrete analysis. And if we look at this figure, so the light gray bars are travel behavior before subscription, and the darker gray is after subscription. And also, if we look at this table, we'll find that after subscribe to MaaS, the travelers tend to be more multimodal, and they tend to use car less. However, it does not mean that they become more sustainable because they also increase taxi use a lot. So after the general impact of MaaS, let's look at the impacts of uncertainties. So first, we find that as the probabilities of uncertainties increase, the risk attitude parameters become more significant and negative, and also the probability of people subscribing to MaaS decrease, which means the more uncertain the travel's behavior, the travel's demand is, the less likely they subscribe to MaaS, which I think is intuitive. As for their risk attitude, we find that most respondents are risk averse to both uncertain travel time and travel cost, but they have stronger aversion to uncertain travel time. This is very interesting because so in my PhD I did not similar. I did a survey in terms of uncertainty, but I did that in London. So in London, it is clearly that people are more sensitive to uncertain travel cost. But this is Hong Kong. So, Hong Kong is a very fast-paced city, so maybe that's why people in Hong Kong are more sensitive to travel time. Although most people are like this, we still identify two smaller groups with different risk attitude. When it comes to loss attitude, we find that, again, most respondents are slightly loss aversion to travel time, and their attitude towards loss in travel cost is insignificant. Again, there are two smaller groups with different attitude. When we jointly analyze their loss attitude and risk attitude, we find that for travel time, risk-averse individuals are more loss averse. But for travel costs, risk-seeking individuals tend to be more loss averse. So very differently. We do not yet know the reason behind that because I think this is the first study that jointly analyzed risk and loss attitude. So we plan to do more investigation on this point later in this study because this is a Hong Kong case. Maybe if we do that in Seoul, the result will be different. Okay, so based on the main findings, we can have the following insight towards the development of sustainable transport and MaaS. So first, we find that MaaS subscribers are more likely to have these attributes like higher education level, lower income, and having at least one car in the household. So when marketing, the MaaS platforms can develop targeting marketing strategies for these kind of people. Second, we find that after subscribing to MaaS, respondents tend to be more taxi-oriented. So maybe the operator needs to impose upper limits on taxi fare discounts in order to prevent the overuse of taxi. We find that when the probability of occasional activities increase, travelers become more hesitant to subscribe to MaaS. So the operators may consider offering a trial period to reduce subscribers' perceived risk associated with the service. And also, since travelers are more sensitive to travel time in this case, so if an operator wants to do their business in Hong Kong, maybe the operator should prioritize improving their service efficiency rather than the cost sensitivity to tailor Hong Kong people's preference. And also, we found that even for risk and loss attitude, travelers have heterogeneity. So the operators can diversify their offering, such as introducing a fare log feature to cater risk and loss aversion customers, or introducing last-minute booking for that offers significant discounts for late reservations for risk and loss-seeking customers. So as I said, this is still ongoing research. We have 2 papers under review, which focus primarily on the impact of uncertainty and MaaS bundles on the mode choice for each journey. So one of the papers is already on the second round of review. So hopefully this paper can be published very soon. And next time I can introduce the findings in these 2 papers. And they are all very interesting. So all of the results are very interesting. So thank you very much. And that's all my presentation. If you have any questions, raise your hand or send me emails. Yeah.
Thank you for your presentation. It was very interesting. And I have one question that you made some model like
EUT. Yeah.
Based on the survey. But I think most of the survey has some bias with some human bias. And I think you must handle some bias in survey. And can you explain how you handle the bias in human bias?
So can you give me examples of the meaning of so can you explain what is human bias you mean?
Like for me, I study I'm not sure you know about the TOBIT model. TOBIT model.
Uh-huh.
There's some theory that people have bias when their survey x-axis component is only like 0, like age, 0, 1, 2, 3, like this kind of age, and there's no negative value. And when we fit this survey value, then this model can be biased like in the negative. Very hard to explain, but when people make decision or make a call, they have some hesitation or make some bias based on their choice, because their choice are not all the axis, and the choice is some truncated or censored. So based on this data, when the fitted model can make some error in some region.
I don't know if that is related here. Yeah, I think so. I understand your question. And TOBIT model, I think we use that in other models, but I'm not sure if it fits this case. Yeah, because so for example, this is travel behavior. So this is like travel cost and travel time. How can it be negative?
I think it's related alternative, right? For example, you mean that human's choice. Human's choice if it's discrete.
Yeah, discrete and like.
Then if it's discrete, then you use the logic model. The reason why you use TOBIT model is because your outcome variable is continuous and you only have the positive value, right?
Yeah.
So your question is, if you ask them to answer some question and their perception is different than what you set for the option?
Yeah, I mean the input value is like not all the axis, because like model, we input some input and then output is a utility, but the input is some kind of only positive value, and when we fit this model in this region, then this model can be biased. So the output
Input you mean the X,
is x-axis
the explanatory variables?
here.
So you mean that the explanatory variables, sometimes when they perceive, they are not perceiving the setting you set. Can you explain it again?
Yeah.
So probably you mean that the y so y versus x is like so well there's no this part, and in the so positive part is like this, right? So first I think Tobit model is so it's a more advanced linear regression, and in our case it is not linear regression, it is logic model. So logic model, so first there's no like order in our logic model, so you cannot like order your y values in this way, because in our case it's simply by or not by, and so for data like this, we usually use logic model. And in logic model, I think logic model is like this shape. So it's only 0 and 1. And so I don't think Tobit model fit this case. And there shouldn't be problem being of human bias in logic model.
Yeah, maybe the logic model is there's no bias, but like I mean this model, you have input variable and the output variable, and then the input variable is like I think the travel time or like this one can be only positive, but the utility can be negative.
Yeah.
So I think is there no
well.
indicate?
Oh, so so in logic models, the value of utility is not that meaningful. So the relative value of utility is more meaningful. So that means whether the utility is -10 or -100 is not that important. However, so for the choices, for example, option A and option B, so compared to option B, the utility of option A is higher. So that's meaningful. Yeah. Okay, so other questions?
I have a question.
Yeah.
I want to ask you a question about your survey data. What's your participants? If you do the survey in the university, your participants are mainly from the students. So how do you do the surveys online or
Yeah.
collect the data?
Yeah. So first, the survey was not conducted in university campus. So there are lots of marketing companies, and you can ask them to help you collect data. So the only thing you need to tell them is the sample, or the target sample and the target population, and also the distribution you want. For example, if you want the gender to be 50% for male and female, you just need to tell them, and they'll help you collect data. And so we use the marketing companies, and also for Qualtrics it is so this company, I think their main job is for you to design your questionnaire. However, they can also help you collect data. Yeah. Our sample are commuters in Hong Kong, so they are employees. So the employees are not students. Yeah. Other questions? Yeah.
So, why you use that EUT theory rather than the traditional common, not this one, it's the prospect one.
Oh, okay.
When we choose, because we have the prospect theory based model, we have random regret
Yeah.
model, we also have that EUT model, expected RUM, right? Random utility maximization.
Yeah.
So when you choose this kind of model, the theory, what is your standard to choose this kind of model? And secondly, you also mentioned about the latent class and also the mixed logic. So which one do you think is better? Because both of them are accounting for the heterogeneity.
Yes, yes.
So usually how you compare them?
Okay. Yeah. Good questions. So first, prospect theory. I think for the EOT models, these are for most uncertain research, people would first try EOT models. They are baselines. The reason we use prospect theory is because of this S shape. Because in our case, it is very unique. So in our choice scenarios, we ask them to compare we ask them to try, if you choose MaaS bundle and you adjust your travel behavior, this will be your new travel time and travel cost. And there we also show you your current travel time and travel cost. Compare these two, which one would you like to choose? So this is very similar to the structure of prospect theory because look at this shape. There's a very clear reflection point. So the reflection point, it is the reference point. So clearly in this case, the respondents compare the travel time, travel cost after MaaS subscription and their current travel time and travel cost. And they may have gains and they may have losses. So it fits this structure very well. The reason we don't use regret minimization is because although for regret minimization, if my understanding is correct, it compares like all possible outcomes with the worst one. Yeah, and in this case, there's actually no worse one because let me go back to the choice scenario. Yeah, because of this structure, their choice is not only whether to buy bundles or not, but also they need to choose how they want to use this bundle. And the combination here, because they need to commute 10 times, and the combination here would be, I don't know, enormous. So that's why it is difficult to get the worst case, and that's why we didn't choose to use regret minimization. And the second question is the comparison of mixed logic and latent class, right? Okay. So I think at least in our group, when we do research, we usually test both, and choose one that is better. And I don't know why, but in this case, both latent class and mixed logic give us reasonable results. I think the reason we choose both is because mixed logic is reasonable first, and it can tell us the heterogeneity, but it cannot tell us the social demographic feature of people with different risk attitudes. So that's why we added a further analysis on using latent class model, because we want to test. So for people with different risk attitude or loss attitude, what their social demographic features are. So this is this study, but for other studies, for example, so there are two ongoing research in our group. One of them we find that latent class models are better because mixed logic we cannot get any results, and the other is on the opposite. So in other study we find that mixed logic we can easily get reasonable results, but latent class not. So this is a very unique case.
So you mean that better result means that the parameters are reasonable and also those goodness of fits indicators are better?
Yeah, so I remember that, so in this case, both results are reasonable and their goodness of fit are close.
And you present all the results in a paper?
Mixed logic in one paper and latent class in another paper.
I have a following question.
Yeah.
Like you said you use the data from the Hong Kong like residents.
Mhm.
So your model can only reflect the local conditions. But if you want to use like your model in other place, you need to start a new
Yes.
story.
Yeah. That's a general problem of behavior studies because so I think most of behavior research they focus on only single place. So maybe you can transfer the result of study to similar cities, like maybe so, because they are all like busy, crowded cities. But if you want to apply the results in other cities like this city, could be impossible.
And I have an idea that whether you can like use the like local statistical data, like the local GDP or car ownership, connect those data with your model to make it more generalized.
You can try, but the local statistics, like the static yearbook, the information is not that in detail because in that so the data in our study they are very in detail because we know the gender, the age, their income level, their car ownership of each individual. But for the statistical yearbook data, you only know like the average for the entire population. Yeah, so it can provide very little information for our case. Okay, any other questions?
Any questions from the floor? If there's no questions, then let's thank Professor Wu again.
Thank you.